Sorry?
The TA, is she gonna join us today? No.
I didn't hear anything. Did you, Drew?
I don't think so.
Okay. So, I guess not. I'm sure she'll get a hold of us at some point.
Yeah.
Um, alright, let's see. Okay, so we're supposed to do part 2 together today. Or did you guys already skip ahead and do that?
I tried to do it, but I don't know. I don't know if I understood it. But I did go through it and attempted it.
Okay. Let's see. Alright. Okay, well. Great, let's see if we... Okay, so you haven't looked at the answer key or anything, though.
Oh no, I have. I compared it to the answer key.
Okay, so then how'd you do?
I did okay.
Good.
Some of it, I'll admit, I corrected with the answer key.
Yeah, but you understood it? Felt like?
I think so.
Okay. Alright, well, good. Then Annie can be our go-to girl tonight if we have any questions.
I don't know about that.
Alright, well, okay, let's take a look at number 4 in part 2. Is everybody there?
Mm-hmm.
Yeah, I'm there.
Okay. Alright, samples of size N are taken from a normally distributed 2011 sales data. What is the shape of the distribution of the sample mean?
I have normal because the parent is normal, so the sample's normal.
Right, so if the parent's normal, it doesn't matter how big the sample size is, it's going to be normal.
Still normal.
Mm-hmm.
Okay, everybody okay there?
Yeah.
Okay, so then number 5, samples of size N equals 40 are taken from a normally distributed 2011 sales data. What is the shape of the distribution of sample mean?
I put normal too.
Right, and in fact, it's a double whammy there because N is big enough and it's a normally distributed parent population. So
Yeah.
So either way, you're going to get normal. Okay. All right. Number 6, sample size of N equals 4 is taken from a normally distributed 2011 sales data. What is the probability that the observed mean is less than 40? In this case, our population mean is 45. So 45 from 40 is going to be 5 or negative 5, depending on how you do that. And then you divide by the standard deviation divided by the square root of the sample size, which is 4. So you can have negative 5 divided by 5. So z equals negative 1.
Yeah.
Yeah.
Right? Everybody okay there? And then you plug it into your applet, or if you saw that, well, it's just 1 away, so then you can use the 68, 95, 99.7 rule or whatever. Then you can do it that way too. But I just plug it into the applet because I think that's easier.
Oh yeah.
Yeah.
Okay. Did everybody get then 0.1587 or ish?
Yeah, close
Put
enough.
158. Yeah.
Okay. All right. On number 7, sample size of N equals 4 again. Taken from the normally distributed 2011 sales data, what is the probability that the observed sample mean is greater than 35 and less than 55? And if we look at how far that is away again from the mean, that's 10 in either direction because 45 is our population mean. And then we're going to be dividing that by 10 divided by the square root of 4, which is 2, or 5. So we've got 10 divided by 5, which is 2. So you're looking at a spread of 2 standard deviations away from the mean in either direction. And we're looking at the space in between them, the area under the curve in between them, right?
Mm-hmm.
So from our 68, 95, 99.7 rule, has to be 95%. You could go that way, or you can plug it into the applet, and it will still give you about 95%.
Yeah.
Yeah.
Okay. All right. Number 8 is pretty much the same thing as number 7. Did you see that? Yeah.
Mm-hmm.
The
Okay.
same number.
So any questions through 8? I'm sorry to go so fast, you guys, but it looks like we're going to have a long evening tonight.
Yeah, that's fine.
Somebody's probably going to look at our video and be like, you really should have spent more time. But if you guys are all okay, then we'll just keep going, zipping through.
Yeah, let's keep going.
Okay. All right, so number 9, a sample size n equals 25 is taken from a normally distributed 2011 sales data. What is the probability that the observed sample mean is greater than 50? So we're going to put in 50. We subtract the population mean, 45. We divide that by 10 divided by the square root of 25, which is 5. You get 5 over 2, or 2.5. You plug that into the probability applet. The probability that the observed mean would be greater than 50 is just 0.00621.
Mm-hmm.
Very unlikely. All right. Number 10. We had problems like this last time. So I'm going to go through them a little bit quick. Number 10 is that the sample size is small and the parent population is right skewed. So then we know that the distribution will be
Hello, and goodbye.
Right, Stu.
right skewed. Good. Sounds like Drew has female company over there. Okay. On number 11, the sample size is large. It's n equals 40. So even though the parent graph is right skewed, the distribution is going to be
Let's put normal.
right. That's right. Because n is greater than 30, and they said for this course, n greater than 30 means it will be normal.
Mm-hmm.
Okay, and then what theorem justifies your answer? That's the central limit theorem.
Mm-hmm.
Okay. All right. And then a sample size of n equals 4 is taken from a right skewed phone sales data, and you want to know the probability that the observed sample mean is less than 35. Can you compute this probability using the normal probability applet with the information you have? Why or why not? Okay, so since the parent graph is not normal and n is small, we can't compute it.
Mm-hmm.
Right? Okay.
Yeah.
All right. Number 14, a sample size of n equals 36. That's big enough. It's taken from the right skewed phone sales data. What is probably the observed sample mean is greater than 36.5? Okay, so we can compute that. We're just going to plug it in to find the z-score. Z-score is negative 1.75, so the probability is going to be 0.9599. Everybody okay with that, or we want to go over that one?
I'm okay.
Annie, that's good? You already did this, so you know.
Yeah, I'm just trying to review it while we're doing it again, make sure
Okay.
I do understand it all.
Okay.
But yeah, I'm good.
Okay. All right. Number 15, sample size is still large enough that we can calculate. Sample mean is between 37.5 and 42.5. Okay. So what I do in that case, when that spread is the same amount to the right as it is to the left of the mean, is I just calculate one of them. Because then you're going to put in your z-score, right, and it's going to automatically do that standard deviation to the right and to the left the same. Does that make sense what I'm saying there?
Kind of.
Kind of. Okay. So, like, for example, in this one, I would just say, I would just take one of them, like 42.5. Wouldn't matter, 37.5 or 42.5, but take 42.5, subtract 40, right?
Mm-hmm.
Go back up here and see sample mean, yeah. 42.5, subtract 40, and then I'm going to put that over the standard deviation, which was 12, divided by the square root of the sample size, which is 36. So I've got 2.5 divided by 2, right? Okay, and that's about 1.25. Bernice. So then when you put that into the applet, it automatically does a z-score of 1.25 on the right side and negative 1.25 on the left side, which is what I would get if I plugged in the 37.5, I would have gotten the negative 1.25. Does that make sense?
Yeah. Yeah.
Okay, so then I'm just looking at that area in between them because it's the same to the right and to the left.
Yeah. Okay. I know what you're saying.
All right.
Okay.
Okay. Are we ready to start the quiz?
I
Let's do it.
think so. Let's just do it.
Okay. Okay. All right. Well, you guys are on your own with 1 and 2.
I won.
And then number 3. Some of these are really long, so I won't read it out loud. Compare you guys that. We'll just do them on our own and then compare. Do you guys have the applet up, or do you need help getting that applet up?
I have it up.
I got
Okay.
one right.
Yeah.
Anna, you're good?
Yeah.
Okay. Just if somebody gets it, go ahead and just yell it out, and we'll compare.
I have .175.
That's what I got too.
Yeah, me too.
Okay. Then I think it's pretty safe.
175.
Yeah.
Okay.
Okay. I got point. I'm gonna keep looking, but I got .055. Anybody else get that?
Oh, I got 0.286. Oh.
Well, I will. Like I said, I'll keep looking. What did you get, Bernice?
0.286.
Okay. All
But
right. Did you plug in 177.6 subtract 185?
I did.
All divided by 26.7 divided by the square root of 48?
Oh, hold on. I think I messed up on the square. Okay, let me redo it because I think I did it. say 176.6 minus 185 over 26.7 square root of 48.
Okay, and what did you get?
I got a negative 7.6. I got 1.068. 1.068.
You got 1.268?
0.68
Okay, that's not what I got. You mean for the z-score?
for the C-score, yeah.
Okay. Let's see. Okay, what kind of calculator are you using?
The computer one.
Okay. Okay, try this for me, Bernice, because it could be an order of operations mistake, and it could be my mistake, but just try this for me. Take 177.6 and subtract 185 and write that down.
Okay, 176 minus the 185, right?
177.6. And what do you get?
I get negative 186.6. I think my calculator is wrong. Hold on.
Yeah, that.
Yeah. Oh. Okay. Negative 7.4. Yeah, that's what I got.
Right. Okay. Right. Okay. So now I want you to just take 26.7 and divide it by the square root of 48, and tell me what you get.
I get 0.556.
Hey, I don't think that's right. So let's see.
Oh gosh, sorry.
No, it's okay. I just don't know what's happening. I don't know why your calculator would do that. Okay, the square root of 48 is going to be around 7, right? Square root of 49 is 7. So you got 26 divided by 7. That's going to be around close to 4. It shouldn't be less than 1.
Yeah, that's true. Because I did it all together, like
But that's what you did the first time, right? Or no? Have you been
I did it the first time, but then I put on parentheses. I did the bottom part, like the 26. I put parentheses 26.7 close and then parentheses.
You should do that. You need to do that, actually.
Yeah, and that's what I got. The 1.068.
Huh.
Let me try to do it again. Did anybody else got something different?
Annie, what did you get?
I don't know if I did it right. I got .152. Is that wrong?
I got .055. We're not coming together here. Well, all right, let's see. What did you get for the z-score, Annie?
I got 1.432.
All right, I've done it 2 different ways, and I'm getting negative 1.9202 every time. So I think that's right.
Okay, well, the formula for the z-score, isn't it x minus the mean divided by the deviation?
Standard deviation, but remember, it's a sample distribution, so it's standard deviation divided by the square root of the sample size,
Yeah,
which
that
is 48 in this case.
You're doing divided by the square root of the sample size?
Yes.
you'll divide the standard deviation by the sample size in the square root form.
Yeah, if you look at lesson 7 and you go down to scroll down to the very bottom, Annie,
Uh-huh.
and it has that, remember that box at the end that most lessons have that say, hey, this is what was really important from the lesson?
Yeah.
The first thing will be an equation. This equation for the sample distribution of means when you're calculating the z-score, that we now take the normal z-score that we would take, and the standard deviation becomes the standard deviation divided by the square root of the sample size.
Oh, see, that's what I'm missing is the Okay.
I keep doing it, and the C-score keeps giving me the negative 1.068. I'm confused now.
Yeah. It is a little bit confusing. I just don't know why they would give us the sample size if they weren't going to have us include it in the calculations. So I really think we're supposed to. But it doesn't necessarily say that this was a distribution of sample means that we're looking at. I mean, I don't know that it has to.
So what did you say you get?
So for my z-score, I'm getting negative 1.9202.
That's what I got.
Is that what you got too?
That's what I found, yeah.
Okay. All right, so what did you get for the area under the curve, Drew?
It's small, right?
Yes.
0.0549.
Yeah, I rounded it to 0.055 since they want it to.
Yeah, 3 decimals. Okay.
Yeah. All right, since Drew and I got the same thing, I'm going to go with it, that we've got it. But let's make sure you guys are on the same page.
I'm just putting the numbers in real quick.
Okay.
So what you say you got in for the area? Of
The area is 0.055. And remember that in this case, we're looking to the left of the z-score and the right of the z-score. That's what it asked us to do. As extreme or more extreme means that we are not only interested in values that are lower than the ones we observe, but also values that are as far away from the mean as ours in the positive direction.
Okay.
The z-score 1.92?
Yes.
Okay. Now I have 0.055.
Yes.
Okay. I think I did my calculator for me. Okay.
Okay. So you guys have me unsure a little bit. Because if you look at number 7, sorry, I worked ahead while we were discussing this.
Oh,
Scores on the quantitative portion of the GRE are approximately normally distributed, with the mean 150.8 and the standard deviation 8.8. Use this information to answer questions 7 through 10. Never mind. Never mind. It doesn't matter. I don't think.
Is number 5 that you can't determine it?
The distribution of the sample means, I have the first one. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of sample means will always have a smaller standard deviation than the distribution of the individual observation.
Is individual mean like all of them?
The 9 different observations that we look at.
Okay.
So it's not the second one, the distribution of the individual observations?
No, it's not the second one. No, the distribution of means will always have a smaller standard deviation than the individual observations.
Oh.
If that doesn't make sense, I think I can explain it.
Which of the following will have a smaller standard deviation if 9 observations are randomly drawn? So is 6 the one, is the law of large numbers then?
Sorry.
Number 6?
Oh, law of large numbers. Yeah, that's exactly what it says.
For number 7, is there a sample size, or are we just dividing it by the deviation? That's it.
We're just dividing it by the deviation. That's it. Because we're looking at one sample or one observation.
Okay, that makes sense.
Okay, what did you guys get for the z-score? Did you get 1.0455? Okay.
Yeah.
If we're going to round this to the nearest 3 decimal places, then this is going to be 1.046.
No, it'll be just 5.
4, 5?
Oh, really? What did you guys get? I didn't get that.
1.045454545.
Oh. Okay, so mine, mine rounded more than that.
Oh.
Okay, so yours went out that far, then we'll say it's that 1.045. Okay, I hope that the professors. Yeah. Okay. Randomly select this.
Okay.
0.148.
Yeah.
0.148.
Yeah.
Number 9, I got 2.338.
Oh, you're ahead of me. You got 2.38. Is that what you said?
338.
Okay, 2.338. That's what I got.
Did you guys already do number 9 or number 10? I had to step away for a second.
So we just finished 9.
Okay.
We're finishing 9. Did you get 9?
I'm just doing it right now. Let me see what I got.
Okay.
2.337?
2.338 is what we said. You round
Oh,
up.
okay. Yeah. Okay.
Point 0097?
Yeah, that's what I
Would we round that up to 0.10?
Nope.
0.010?
This particular 1A, they tell us to round to 4 decimal places.
Oh, this one does?
Which makes me think we're definitely right because they're trying to avoid us having to do that.
Yeah.
Let's see.
Thank you.
Eleven's normal, right?
Yep. Approximately normal because the sample size is so large. Okay, that's going to be 3.5, right? Because the mean of this distribution of sample means is always the population mean.
Yeah, that's true.
You guys have 0.078?
So remind me how we find number 13?
We're going to take the standard deviation and divide it by the square root of the sample size.
Oh, okay. Okay, yeah, 0.078. Or point. Yeah. For this one, are we doing the two areas below 2.5 or just the area below negative 2.5?
Just the area below negative 2.5 because it's just asking that will be less than 3.3.
Was it?
0.005?
Mm-hmm.
Yeah. Okay.
Point 0.
0.995?
Yeah.
Would make sense, yeah.
I'm not a fucking wimp. Yeah, 499.
Okay. Annie, I think your mute button is on. Okay.
They're gone?
All right, should we go over our answers one more time?
Yeah, we can go.
Okay. All right, number 3.175.
Yes.
Number 4.055.
Yes.
Yes.
Number 5. The distribution of sample means will have a smaller standard deviation than the distribution of the individual observations. Does everybody feel comfortable with that answer? Bernice, did
For
you?
service type, that was the second option, but how you explain it, I mean, it makes sense. I don't know.
Okay, so so if you have like, if we're looking at like a population of, let's say, like ages in Sunday school. Okay. You go into any Sunday school. Sorry that I'm using a church example. Is that okay?
That's okay.
Okay, you go into a church Sunday school. There are 100 people, and they're going to range in ages from 18 to, let's say, 82. Okay. Right. So and we're going to draw that graph, that histogram, of who's 18 and who's 92. Or who's 18, who's 19, who's 20, etc. All the different age possibilities. 18 and 82. And we're going to have 100 different possibilities, right?
Mm-hmm.
And it may be this is a young Sunday school, if it's a single adult, I don't know. But in this case, there's the youngest person's 18, the oldest person's 82. Okay, so we've got that parent graph, whatever that's going to look like, right? And the smallest is 18, and the largest we said was 82. Okay, so I know that's a really, really awful rough sketch, but smallest is 18, largest is 82. That's our parent graph. We'll say it's normally distributed. Okay, all right. So then I take a sample. I take a sample from there, right?
Mm-hmm.
And I get a mean. Okay. That mean is going to be closer to my center. Let's say it falls like right here, right? We'll say it falls like right here. Does that make sense?
Yeah,
Okay. All right. Bernice, the likelihood of it falling right here is like almost nil, right?
Okay.
The sample mean is not going to fall here. It's going to fall somewhere in here. So the distribution of my sample means is going to be closer together. And so that's going to make the standard deviation smaller. Does that make sense what I'm saying there?
Yeah, that makes more sense.
Okay, so and I sit here and I say this, but even in me on number 5, I'm going, it could be that it's not determined. I mean, of the two at the top, I do feel very confident it would be the first one. But it could be that we don't know that for sure. I'm pretty sure we know that the standard deviation is going to be smaller. this could be right skewed or left skewed. We don't know what the parent graph looks like, and n is not large enough to make it a normal distribution, but the standard deviation should always be smaller when I take a sample mean. Does that make sense what I'm saying there?
So, for example, instead of 9 observations randomly, if there was a larger number, will be obviously different, right?
Yes. Yeah. So they're looking at the 9 different observations. Well, I don't know. They could be anywhere on this graph, right? I mean, those 9 observations could be anywhere. But if I'm looking at a distribution of sample means, so several different means, they're going to be more centralized.
Okay.
They're going to be closer together. They should be closer together.
Okay.
So my standard deviation would decrease.
Okay.
I hope I'm trying here to convince you, but I'm really hoping I'm right too. Okay.
Sounds like you're right.
Number 6. That's like straight from the definition. That is the law of large numbers. I feel very confident with that one. Number 7. Diane earned a score of 160 on the quantitative portion of the GRE. Okay, we got 1.045. Everybody okay with that?
Yes.
Okay.
Oh, yeah.
Number 8.148.
148. Yeah.
Number 9, 2.338.
Yeah.
Number 10.0097.
0,
Yeah.
Because it said to 4 decimal places in that case.
Oh, yeah, yeah.
Everybody all right with that?
Yeah.
Yeah.
Okay, number 11, approximately normal because n is so large.
Yeah.
Okay. Number 12, 3.5.
Yes.
Okay. Number 13.078.
Mm-hmm.
Number 14.005.
Uh-huh.
And 0.995 for 15.
Yes.
Okay, we're going to submit.
Okay.
100.
Yay! These are starting to get a little harder, huh?
Yes.
You did it.
Okay.
I thought it would become a little easier if I understand more, but now every time it gets a little harder. So
All right.
that's good. Okay.
Well, I know it is easier when you have a TA to talk to or a professor to talk to. I think online courses are harder.
I
Makes you
know.
work harder.
Well, I appreciate it. I got shot in that. Big effing deal.
Well, you guys have a good night.
You too. We'll see you Thursday then.
Yep. Sounds
Thursday.
good.
Have a good night.
Okay, take care.
Bye.
Bye.